All right, welcome to part 3 of drawing simple graphics in XNA. In this video, what we're going to do is move into the cat demo. First, we're going to demonstrate sprite effects. It's real quick, real simple, how to take a sprite and flip it vertically or flip it horizontally. From there, we're going to take a look at blending, more specifically the sprite blend modes, none, alpha blend, and additive. Alpha blend is the default. We've been using it, and you've already seen it, but you may not realize it, so we'll point that out. Once we've taken a look at that, when showing additive, it's kind of hard to see the effects. So what we're going to do is we're going to create this circular move routine, and then we're going to use some vector 2 interpolation, and we're going to layer a whole bunch of these sprites and have them kind of all moving around in a circle. It's going to be pretty cool stuff, but that's going to allow us to really give a really cool demonstration of additive. So Logan, with that, let me go ahead and turn it on over to you.
All right, let's jump over to Visual Studio and create a new project. I'll call this Sprite Blend Example.
Sounds good.
All right. And now I want to get the textures that we'll be using imported. So I want to begin with a new folder, which we'll call Textures. Then I want to jump out to our source folder where we have now an additional graphic, a cat graphic to go along with our sprite. I'll copy both of those, and then I'll jump to our projects folder under this new Sprite Blend Demo folder, or excuse me, a few up. This is, okay, just so same folder. This is the simple sprite we created in the last video. Now we have the Sprite Blend example. We'll jump into that. We have our textures folder.
And there we go.
And we can paste the graphics in there.
And a real quick setup over here.
So we'll add existing items.
Okay.
And we're into the Sprite Blend. So we'll grab our textures. We need to change the types of files to content pipeline. And then we can grab both files, add them, and now we have the cat and sprite headed in, which will get generated as assets now.
Okay, next our variables.
All right, next we need some variables. We need, of course, a sprite batch. So I'll make a sprite batch, and I'll call this field, again, sprite batch. And I also want a texture 2D field so that I can hold a reference to a texture. And I'll simply call this texture.
Okay.
All right, next part of the setup will be to create the sprite batch. To do that, we'll jump into Initialize, and we'll set our sprite batch equal to a new sprite batch. Sprite batch, of course, has to have a graphics device, so we'll give it graphics.graphicsDevice. All right, the next step in the setup is to load in the texture and to fill that texture 2D reference. So I'll jump down to Load Graphics Content, into the section for Load All Content, and then we'll say that texture is equal to content.load. We're going to be loading a type of texture 2D, and then the asset name, I'm going to begin with the @ symbol for literal string, then we'll give it the path textures\cat, because we want to get access to our new cat graphic. Alright, that has the cat texture loaded into our texture 2D field. Now we can focus on drawing. To begin with, let's simply draw that cat graphic in its default form at 0, 0, just to see what this graphic is looking at, so we get an idea of what we're working with here. So we'll begin, or we'll make a call to spritebatch.begin. Then I'll make a call to spritebatch.draw, and I'll use the second overload so that I can specify our texture, the position vector2.0, and the color.white. Alright, after our draw, I'll make a call to spritebatch.end. And I didn't mean to jump down, so end. There we go. And everything is looking good, so let me now build and run. If we build and run, we see, there we go. There is our cat graphic.
Isn't that great picture? Okay, so first thing we want to do is demonstrate sprite effects, so let's see how we can flip vertically and horizontally.
Alright, let's look at the overload and see how far we have to go to get sprite effects. I think we'll have to go for overload 6 again, because I want to keep using the vector position. So let me put a call together for overload 6.
First, before we do that, do we want to go ahead and define a local variable of sprite effects?
That would be a good idea. You can see down here, once we get to effects, it's going to be a type sprite effects. So to make everything more clear, what I could do is begin with a variable of type sprite effects. And also we call it sprite effects. And let's start that out with a value of spriteEffects.none to mimic the call we had done in the last video where we weren't specifying anything. Alright, now let's extend our call to draw here. We need overload 6. That means directly after the position we need to specify whether or not we're using a source rectangle. I'm going to give null since we're not. Color is already filled in. Rotation, now a lot of these I'm just going to put in a simple numerical value since all we're focusing on here is sprite effects.
Right.
So for rotation, I don't want any rotation. I'm going to give it 0f. For origin, I don't want to specify an additional or specific origin. So I'll give it vector, excuse me, wrong typing, vector2.0. For scale, I'll give it 1f. Now, sprite effects, finally, we can plug in our sprite, let's see, sprite effects variable. And then finally we're presented with layer depth, which I will give a value of 0f. So there we have a call to draw where we're specifying sprite effects. Sprite effects being set here as sprite effects.none.
So if we run it right now, it should look exactly the same.
And it does.
So let's start out by flipping it horizontally. So instead of the cat looking to the left, it's looking to the right.
Alright, let's give a sprite effects.flip horizontally. And hey, what do you know?
Now looking to the right. Very good. Now let's take a look at flipping it vertically.
Okay. So we'll specify sprite effects.flip vertically. And it does just that.
Now he's just holding on to the ceiling. And now, how can we combine the two, Logan?
Well, if we want to combine these effects, first is to understand just what this value really means. All these values really are flags, numerical flags, held within sprite effects. That means they could be combined using bitwise operations.
Very good.
I know it's been a while since we talked about operators, so we'll kind of go through this quickly. But basically, we could use the bitwise operator or the pipe symbol to combine these numerical sprite effect values. So we could say sprite effects.flip vertically combined to sprite effects.flip horizontally, and we have a resulting flag that the draw method will understand as flip both vertically and horizontally.
So now he should be hanging upside down looking to the right. And he's hanging upside down looking to the right. Very good. So that is a very quick look at using sprite effects. I mean, it really is that simple. So now let's go ahead and shift gears, Logan. Let's start off with talking about our blend modes, and let's see if we can demonstrate exactly what's going on, because by default, it's alpha blend. So I want to show that first with maybe a couple cats.
Sure. If you don't mind, I'm going to clean up the draw calls now. Since we've seen sprite effects, I'm going to pull that back out of the mix. Since when blending, we're not going to worry about which way the picture is pointing.
Right.
So I'm going to pull this all the way back down to overload 2, where we take out our source rectangle and a bunch of the other parameters.
Yeah, keep it simple.
Alright, so we're back to drawing a cat at 0. Now, in order to show blending, let me get multiple sprites in place here. And before I do that, let me define two positional vectors. So we have two different positions on the screen, and then we'll draw to those positions. So we'll start with a vector 2 for position 1. And we'll set this one to simply vector 2.0, so no change there. But then let me specify another vector 2, this time called position 2, and let me give a new vector of maybe 200 by 200. I might lower that a little bit if the pictures are too far apart.
Right.
That's a good starting point. Now we'll make our first call using the cat texture at position 1. I know that's really not going to cause any difference. But now we can copy this line and make a call using position 2. Now let's also specify, I know you had said that the default blend method is alpha blend, but let me specify that explicitly with the call to begin.
Sure.
Let me bring up the overloads, Control K, Control P again, and jump down to the second overload, where we can specify a sprite blend mode. So let's look at what's in sprite blend mode. We have access to sprite blend mode dot additive, alpha blend, and none.
Okay.
So let's make sure that we're explicitly giving it alpha blend. And then let's draw two cat pictures at two different locations. Because at this point, it might make sense to think that, okay, well, we're going to start blending the images. But let's run and see what happens. We have two cat pictures and no visible blending taking place.
Right.
The reason for this is this cat image does not have an alpha channel. And then in the final compiled format, it has technically an alpha of completely opaque. But in the end, the alpha is saying that this image should be opaque, and that is what is happening even though we have alpha blend.
How about let's switch the cat over to the sprite image, because that one does have an alpha, so that we can show that with an explicit setting of alpha blend, we're going to get the exact same effect that we saw in the last video.
Okay. let's jump up to where we were loading our graphical asset, where we're loading in the cat asset. Let me change that over to Sprite. So we load in that original spiky sprite. And now, while they're not drawing over each other, they are indeed alpha blending because they're blending over the background. Now, to make it clear what happens when they draw over each other, let me adjust my second position. Maybe something more along the lines of 32 and 32. So we actually get the graphics, well, almost. Not
that
quite.
Was awesome.
16 by 16.
That'll work.
And there we go. We can see that the background graphic is still visible in between the spikes of the foreground graphic, as well as the background blue color being visible in between the spikes of all.
So the blending is working well. Now we can actually turn off the blending by specifying none.
So if we change this to sprite blend mode dot none, look what's happening here.
We blew up the graphic.
So now we're telling it to perform no blending whatsoever between sprites. So every sprite is going to completely fill its entire rectangular area with some color. And what color this is can vary depending on how the graphic was generated. Apparently there's some actual color data outside of the alpha. So we're seeing some color data drawn. Other possible effects are where you'll see the very edge of the graphic get stretched to the end of the graphic. But bottom line is you won't see any blending.
Right.
Because we have specified no blending in sprite blend mode dot none.
So if we switch this back over to cat, do we have a means of actually blending between the two?
We can enforce an alpha if we change the modulation color. Let me show you what I mean. If we bring the cat back in and we change our blend mode back to alpha blend.
Let's go ahead and specify 200 by 200 again.
Sure. Let's get the original spacing back. Now, of course, we're not seeing any alpha because, as we talked about, this image doesn't have a transparent alpha. Now, what's interesting about this modulation color is we can specify any color that we want for this. We don't have to use the preset ones. What I mean by that is we can instead specify a new color, and in color we're given a set of overloads in order to create a color. We can use a vector 3, a vector 4, or we can specify individual bytes. In overload 4 we could give a byte for red, green, and blue. But in overload 5, we're given not only red, green, and blue, but the ability to specify an alpha. That means the modulation color can contain an alpha.
Very nice.
If we apply that to our cat picture, then we can basically include an alpha into the final rendering. So what that means is I want to give the color white, because I don't want to affect the color of the cat picture.
Right.
So I'm going to give 255 for the red, green, and blue bytes. But when we get to the alpha, let me lower that way down. Let me take that all the way down to 64, so we have roughly 1/4 of the opacity that we had before. And let me copy this line and do this to both. Or do you want to see it with only one?
Just one.
Okay. This is, of course, going to be the first one, so we're still going to be hidden by the second opaque one. But look what's happening now. We're actually blending to the background color at the moment.
That's right.
So I could actually swap this around. Now, if you want to see the foreground cat image being blended onto the background one, I'm simply going to swap the colors we're feeding. So now the top left cat is going to be completely opaque, whereas the bottom right top cat is going to be transparent.
Very nice.
Or I could, of course, specify this transparency color for both of them, and then they'll blend to the background and over each other.
Very cool. Which this sets us up nicely for the next one to take a look at. We already know none means no blending. Now we've got alpha blending, which is our default mode. Now, how about additive?
Okay, let's take a look at additive. As a matter of fact, we can play around with the alpha a little bit more to show whether or not that's required. But first, let's change the sprite blend mode over to additive and do a simple run.
Okay.
This one is a little hard to see because of the blue background. This is getting very close into needing that circle routine we were talking about.
Let's start out by changing it to black.
That'd be a good idea because that'll also help later when I want to get the final effect. So I'm going to change the graphics clear color to black.
And you can see it right there.
It is, in fact, you can see in additive we're increasing the color value because we continue to add. Let me show it this way. Let me for now take our color. Let me just change this alpha where I'd specified as 64. Let me turn that all the way back to opaque with 255.
Sure. Make it even brighter.
And we'll do this step by step. One image then would now look like this in additive. It looks perfectly correct, but that's because we started with a color of black. If I change the color or add another cat into the image, we can see that in the combination area, the overall value is increasing.
Meaning it's brighter.
And we could even bring the color just from a second back to the cornflower blue. and show we would get a result like this. An extreme overbrightness, because we started with a color that already had significant brightness value to it. The blue was relatively bright.
That's right.
Then we add in all of the possible additions from the cat graphic, which got even brighter, all the way over to white in some cases, and then even more of an overblown effect when we started to lay the pictures over each other.
Exactly.
And you'll also note that additive blending is taking place even though we have a completely opaque alpha. Of course, we can introduce alpha into it, but that's simply going to reduce the amount of adding that takes place.
Cool.
So that really shows all three blend modes, but at this point
we're ready to do something a little more interesting.
Yeah, let's show a different way of actually demonstrating additive and one of the effects one can achieve.
So we've done sprite effects, we've done blending, we've looked at none, we've looked at alpha blend, we've looked at additive, but we're going to push additive just a little bit more by creating a group of textures that are layered on top of one another and having them move around in this very interesting circular pattern. So it's time for us to create a circular move routine. So let me go ahead and give you control back.
Okay. Circular move routine. Basically what this is going to use is game time, and then we're going to use sine and cosine in order to achieve the actual circular motion.
Okay.
So let me write out this method and I'll explain what all the pieces do. I'm going to declare this as a private method because there's at the moment no reason to use it outside of the game class. I want to return a vector 2 because the whole idea of this method is that it returns a position that will move over time. That way I can continue to use my position 1 and 2 vectors, but I'll simply get them from the circle move routine.
So you're constantly returning a new position right here.
Exactly. After every call we return a new position that should be on another advanced place in the circle.
Okay.
Of course the name is going to be circle move. And now, what arguments do we want to take in? Well, let's first take in a game time.
So that we can get some sort of value that is constantly changing over time.
More specifically, we'll get the total seconds, a value that is constantly increasing as the game progresses. So I want to take in a game time parameter. I'll call the parameter game time. Next, I'd like to take in a position. This means you can almost call this offset position. But basically, when I create this circular movement, I want to actually move the overall circle to anywhere I want on the screen. And I'm going to specify that position using a vector 2. I'll call the parameter position. Next, I want to specify a parameter called frequency. What this is actually going to do is it's going to drive the frequency of the sine and cosine, and the visual result of that is the frequency will be the speed at which the vector in question moves in a circle. So I want to make a float value for this called frequency.
Spell it.
And Q, U, and E go the other way. Q, U, E,
F-R-E.
F-R. Wow, that was really butchered.
All right, good.
Right, there we go. All right. Next, I want to specify amplitude. What amplitude is going to do is I'm again going to apply it to the sine and cosine.
So how big?
Yeah, how big is the, theoretical waveform that we're making? That waveform is actually represented as a circle, so what that'll show is how big the circle is.
Right.
So I'm going to call the parameter amplitude just for its relationship with the sine and cosine sine wave. And then one last thing I want to specify is a float called offset. And what I want to do with this offset value is, since the position of the sine and cosine are going to be based on time, that means that pretty much the position that we're at inside of a circular motion is going to be based on the exact time we are looking at within the game. In order to have two things follow the same circle but be in different positions along the circle, basically means they need an offset in time, since the time value controls where you are in the circle.
Right.
And that is all of the parameters that I need for circle move. Now let's put these into place to get an actual circle back out. The first thing I want to do is I want to make a value to hold some modifications to time, since we'd already talked about the offset that we need for time, and I want to apply frequency to time as well. I'm going to do this entire operation and store it before I get on to the sine and cosine. So what I'm actually going to do is make a double variable called timeVal, and we'll set this equal to GameTime.TotalGameTime.total seconds plus offset. And then I want to take the overall result of this and multiply that by frequency. But since multiplication is going to take precedence, I'm going to enclose the total seconds plus offset in parentheses. And take that result times frequency. So we get time value, possible offset, then the overall value multiplied by frequency, so we can control how fast time is advancing. Now we can look at using the math.sine and cosine to generate a vector 2. And I'm actually going to do all of this on the same line as the return for the method. So we'll say that we're going to return a new vector 2 where the x component is going to be math.sine, or sin, for the time value. So we'll plug in time val. Now, since the vector 2's components are floats and sine is going to return a double, I need to make sure that I cast this result over to a float. Alright, so that is going to be everything for the x component. The y component is going to be the same thing except using the cosine function. So we'll change sine to cos for cosine.
And that's where we're going to get our circle from.
And yes, that is indeed our circle. Now I do want to take this resulting vector 2. I still have a few things to apply. We still need to apply the overall amplitude, but since this is a circle, this will apply to x and y in the same. So I can take the overall vector times amplitude. Now I still need to take into account our original position offset, but at this point we're dealing with vector 2's, so I can simply add on to this position. So there. A bit of math, but all that's put together. I want to do a build now to make sure that I haven't introduced any syntax errors. I have not. Everything built successfully. So let's now use circle move to gain our positions. So let me erase the 0 value from position 1 and instead set this to the result of our new circle move routine. And circle move is of course going to need a game time. It's going to need a position to start out with. And for that I'll give a new vector 2 of 150 by 150. So I'll start both of these somewhat spaced off the top left of the screen.
Okay.
For the frequency, I'm going to give a frequency of 2f. And for the amplitude, we'll give it a value of 150f. Now for the offset, I'm going to use this as the beginning one, so I'm not going to specify any offset. We'll just leave the time offset 0. And that should give our first position. Since it's already in use, let me go ahead and run and just see what this circular motion is looking at. So there is our first cat graphic moving around the scene.
Very nice.
Now all that's left is to give ourselves an offset on the same circle for position 2.
Let's go ahead and change that background color real quick back to black.
Okay.
It's just so blown out being an additive.
Let's bring it back to black so we have something much nicer color-wise. Alright, what I want to do for the second circle is have a circle of the same radius, but offset in position and offset in time. Let me show you what I mean with that. I'm going to begin by copying the line since it had several parameters. We'll paste it over position 2, but change the name, of course, back to position 2. Now for the offset, I want this circle to actually exist over the same position. So I'll actually go back on what I said a second ago. I'm going to leave no positional offset. So basically we're going to have two circles centered around the same place. The only difference is going to be their time offset. So we'll have one cat picture that's kind of drawn at the top left when the other cat picture is drawn at the bottom right.
So you're going to put them 180 degrees out of phase.
Out of sync.
Okay.
And I'm going to specify some magic numbers in this case. So I'll do 3.14 divided by 2, so in essence pi divided by 2.
Yep.
I'm not going to specify any constants because I don't want to get into any really high accuracy here because I don't need it. But this is what I'm going to specify, and we'll just leave it at that.
Yeah, when one picture is at the top, we want the other picture to be at the bottom.
And let's run.
And that's exactly what we get.
There we go. Two pictures that almost look like they're orbiting each other. But very nice. We do have some circular motion. So that really takes care of the circle move objective, and that leaves the draw sequence objective, since we still only have two images. And we had talked about the idea of taking two positions and putting a series of images between them.
Right.
So that'll lead us over into the next method I want to create, the draw sequence.
And before you start creating it, just give an overview of how it's going to work. We're going to loop through.
All right, well, basically what I want to do with draw sequence is I want to give it two positions. So we have basically a starting position and an ending position.
Okay.
And in addition to that, I want to specify a number of segments. And I'll use that to say how many sprites do we want to put in between these two positions.
Okay.
So the idea there is that inside of this method, we start a loop. And we loop for however many segments we've been given. So if we are given 15 segments, then we'll start a loop that will go over 15 iterations. Inside of this loop, we'll come up with a third vector 2 based off of positions 1 and 2. What this new vector is going to be is a position somewhere in between position 1 and position 2.
Based off what segment it is.
Based off what segment it is. We'll use the vector2 linear interpolation function in order to do this, so we can specify our two vectors. Then we're allowed to give a float in a value, or excuse me, a range of 0 to 1. 0 being the first position, 1 being the last position.
Okay.
So let's take a look
So we
at
end up with a
together.
stack of images, basically however many segments we have, that are evenly spaced apart.
Exactly. All right, let's take a look at drawing all of this, and hopefully it'll become a little bit more clear. This is going to be a private method. I'm not going to return anything with it, so I'm going to use a return type of void, and we're going to call this method drawSequence. So draw sequence. All right, I'm going to take in a few things here. The three things we talked about: position 1, position 2, vector 2s, and an integer for number of segments. So vector 2, position 1, vector 2 for position 2, and an integer for segments. All right. First thing we need to do inside of the method is our loop. I'll make a for loop, and I'll leverage the template, so tab twice will drop our template in place so that I have quick access to the length, which I'm going to replace with segments, since segments is the number that we need to loop over. So we have a loop now going through all segments from 0 to 1 less than number of segments. Now I need to get that third vector, this vector that is going to be an interpolation of position 1 and 2 depending on how far into the segments value we've gotten. So I'm going to make a vector 2, I'm going to call this vector 2 current position, or current position. We'll say that is equal to a new, or excuse me, not a new, rather the result of the linear interpolation. So current position equals vector 2 dot lerp for linear interpolation. If we open this up, we see that the overload we're going to use is a source vector, vector 1, second vector, and then an amount to interpolate between the two. So let's put in position 1 as value 1, position 2 as value 2, and the amount indicating which, or how, weight of, I was thrown off by the weight being written down here in the in the tooltip. Basically, we want to say, are we at 0, so position 1, are we all the way at 1, or are we at some value in between? And this gets a little tricky because we have to obtain a 0 to 1 range. And right now we're looking at a 0 to number of segments range. So in order to get this range, what I'm actually going to do is take I and divide that by segments. So this means that when we start out, we have I set to 0. So 0 divided by number of segments, let's just say that was 15. 0 divided by 15 will return 0, and we'll be all the way or stuck to position 1. Next iteration, throw off 1 divided by segments, which will be some decimal value all the way up until number of segments where we should get 1 or very close to 1.
Yeah, since
now,
we're not actually at segments.
One word of caution here is that both operands are integers, which means that we'll be dealing with integer division unless we cast one of the operands to a float. And we definitely want a float in this case because we need a floating point value to feed to the linear interpolation. And also I need to fix my... No, I was messed up by these parentheses. Alright, there. That should take care of current position. Now all that's left is to draw a sprite at that position. So we can do a sprite batch.draw. I want to draw the texture field at the position, current position, with the color. I do want to copy the color we're using because we've got this kind of alpha thing going on. So let me copy this new color we're creating. I know it isn't absolutely necessary to have an alpha when using additive, but the number of sprites I have in mind is going to need to be reduced in alpha down to about quarter. So let me plug in 64 there. Again, this could have been white, but the ending result will look a little better in this case. And I believe that's everything I had for draw sequence. Let me build, check against syntax errors, and we're looking good. So now what I want to do is replace our calls to spritebatch.draw with a call to draw sequence. So let me pull both of these out, jump in here, and draw a sequence over position 1 to position 2 with the number of segments being 15. Alright,
we'll give it 2 segments to begin with.
Okay. Start simple.
Or 3. Yeah, 3 is good.
Alright, let's give 3 segments from position 1 to 2.
Alright.
Ooh, that's kind of trippy. We have the cat picture drawn over itself with additive, though we aren't getting too much, or well, any of it over overdrawn effect, but we aren't using very many sprites, and they're all very transparent because we started out with an alpha. We have a black background, so we have very dark colored images to begin with.
And you'll notice that the spacing between the three images are equal.
Right, the spacing is equal, and there's actually a lot of spacing because we don't have many images to cover the distance.
Right. So now let's set it to something like 15.
All right, let's up this to 15. And remember that we are still in additive mode. Wow, look at that.
Big difference. Very cool looking.
So to begin with, we have a lot more sprites placed a lot more closely, and since we're using additive, we get to the point where we overdrive some of the center of the image because so much of that light color is getting drawn over itself so many times with additive that we actually reach the color white.
So how crazy does it look if you do something like 30?
Well, probably pretty bright.
Just all bright.
Pretty much.
Yeah, pretty much. So let's change the mode.
Yeah, let me change the segments back to 15. I kind of dig that effect.
Mm-hmm.
Now let's compare additive with alpha blend using this many sprites. So let's change the blend mode back to alpha blend.
Wow.
So we get a really nice glass box looking effect, but we get blending and no over multiplication or overbearing effect.
Right.
So we can never really increase in value because we're modulating the colors instead.
Oh, that's
so
trippy.
we can see a lot of the colors as they fade back into this series or the stack of images.
And go ahead and set it to none real quick.
And we could set it to none, which will disregard any alpha we had seen before. We'll disregard the alpha in the sprite graphic, or in this case, we'll disregard the alpha specified by the color. And see what that means. And now we have everything drawn completely opaque. So every subsequent graphic completely overdraws its area for the any graphic behind it.
Very cool. How about we switch out the cat for the sprite? I bet that'll look interesting.
Sure. Let me change the blend mode back to alpha blend.
Okay.
Actually, let me change a few things. I'm going to change this back to alpha blend. We have this, or just keep in mind that we have an alpha being specified here. So at first, when I bring the sprite back in, it's going to be rather transparent. Cool looking, but
very
transparent.
cool looking, yeah.
Let's bring the opacity all the way back up. So let's take that alpha I had specified and bring that all the way back up to 255.
Wow, very cool.
So I've got a kind of pseudo 3D effect going on just because of the fact that each subsequent sprite overdraws the last, so we get a progression looking effect.
Very nice. Logan, is that pretty much everything we were looking to demonstrate in this video?
That was everything that I wanted to show, the core of which just being the blend modes, showing none, alpha blend, and additive.
And we will be revisiting these again in the future.
And yeah, all of that, the rest of the demonstration was pretty much just a bunch of math to accomplish some circular rotation and then a sequence.
It was just cool bonus stuff, so that we did something interesting.
Added a cool effect at the end.
Yeah, without a doubt. So if we go ahead and jump back over here real quick. So that takes care of a look at a circular moving routine with game time, sine and cosine, and using the linear interpolation method that's built in with Vector 2. All right, so that everything that we're looking for?
That's everything I wanted to cover.
Let's go ahead and jump back over here. Let me give a quick thought. And thinking. No, that's it. All right, so with that is going to wrap up part 3, and then in part 4 we'll basically wrap up this mini-series on an introduction to the Sprite batch with a look at sprite sheets. So that wraps up this video. Thanks a lot.